Hello everyone, welcome to Cracku DILR series. In this series, we are covering 100 plus CAT level DILR sets for CAT 2026, covering easy, moderate and hard difficulty levels. In this video, you will get one complete DILR set and the PDF will be mentioned in the pinned comment. Download it before you start. Pause the video, try solving the set by your own and continue to watch the video. If you're preparing for CAT 2026 and want a serious DILR practice, then this series is for you. And if you want more DILR sets, we have thousands of them. It's very simple, just go to Google and search Cracku DILR sets.
In this question, we are told that there are some bottles and each of them contain 50 ml of liquid. They can be either 100% pure or they can contain some impurity. We are told that once some testing is done, if you take some samples from some bottles and do testing, if the percentage of impurity is greater than 10%, then it will detect impurity. If it is not greater than or equal to 10%, say the percentage impurity is say 8%, then the test will not detect any impurity. Now let us go ahead and answer the questions that follow. 5 ml of content from bottle A is mixed with 5 ml of content from bottle B. So A and B have equal content, both of them are mixed. The resultant mixture when tested detects the presence of impurity I. This would imply that the overall percentage of impurity when both of them are mixed in equal proportion is greater than or equal to 10%. It is known that A contains only P, or the percentage of impurity in A is 0%. If the average impurity in A and B when they are mixed in equal quantities is greater than or equal to 10%, if A contains 0% impurity, it would imply that the percentage impurity in B has to be greater than or equal to 20%. Only then will, when you are combining both of them in equal quantities, will the average percentage of impurity be greater than or equal to 10%. We are required to calculate what best can be concluded about the volume of impurity in bottle B. It is given that each of the bottles contains 50 ml of liquid and the percentage of impurity in B is greater than or equal to 20%. So the volume of impurity in bottle B is greater than or equal to 20% of 50 ml, which is equal to 10 ml. So the impurity is greater than or equal to 10 ml, which is option D. Let us now look at the next question. We are told that there are 4 bottles and each of the bottle is either completely pure or completely impure. Now we are required to dispatch them, or they will be considered to be ready for dispatch only if they are all completely pure. So how many tests are required to determine whether they are collectively ready for dispatch or not? Now let us consider some cases. In the first case, all the 4 bottles are completely pure. In the second case, 3 bottles are completely pure and 1 bottle is impure. In the third case, 2 bottles are pure and 2 bottles are impure. In the fourth case, 1 bottle is pure and 3 bottles are impure. In the last case, all the 4 bottles are impure. Now if you are doing a test where you are taking a small sample from each of the 4 of them and you are testing whether there is impurity or purity. In the last case, the test is going to determine that it is impure, because the percentage impurity in this particular case will be 100%. In the earlier case, the percentage impurity will be 75%. So when a test is done by taking small samples from each one of them, it will be determined to be impure. In the third case, if 2 bottles are pure and 2 bottles are impure, the percentage impurity, if you are mixing equal quantities from each of the 4 bottles, will be 50%. So the test will again determine that this is impure. In the second case, if you are mixing equal quantities from each of the 4 bottles, the percentage impurity will be 25%. So the test is going to determine that this is impure. In the first case, when all the 4 bottles are completely pure, we have 0% impurity, and so the test is going to determine it is pure. So if the test returns that the sample collected is pure, only then is it completely ready for dispatch. In all the other cases, it is not completely ready for dispatch. So by conducting just one test, we can immediately identify whether this sample of 4 bottles is ready for dispatch or not. So the correct answer is one test is sufficient. Let us look at the next case. We are told that there are 4 bottles. It is known that 3 of the bottles contain only P. So we have 3 P and 1 I, but the 4th one, let us say, is P star, because this contains 80% pure sample and 20% impurity. Now we are required to find out which one is P star, that is which one is the bottle which is not 100% pure amongst the 4 bottles. We are required to do it in minimum number of tests that is required. Now if you are mixing 3 bottles, one of them is P star and the remaining 2 are completely P. In that overall sample, what is the percentage of impurity? That will be 20% divided by 3, which is equal to 6.67%. This is less than 10%. So if you are mixing 3 bottles or 4 bottles, your test itself becomes completely untrustworthy, because even if there is some impurity, because it is less than 10%, we will not be able to determine whether it is actually pure or impure. So we should mix only at max 2 bottles. One easiest way, very inefficient way of testing and finding out which one of them is the impure bottle is by taking a small sample from each one of them and measuring them independently. So within 4 tries, you will figure out which of the bottle contains impurity. But that is inefficient, we can improve upon it. How are you going to improve upon it? We will mix 2 bottles, 2 samples from the first and the second bottle, small samples of equal volume, and we will mix small samples from equal volume from 3 and 4 also. We will first test 1 and 2. If 1 and 2 contains P star, that is if one of the 2 bottles actually contains some impurity, because the impurity is 20% in that bottle individually, in this sample the percentage impurity will be 10%. So immediately the test is going to determine that okay, there is some impurity. So with one test we can identify that okay, the impurity is lying either in bottle 1 or bottle 2. Then we will check bottle 1 separately and we will identify if it is impure. If the test is rating impure, then the impurity is in bottle 1. If the test is rating pure, then the impurity is in bottle 2. So by doing 2 tests, we can easily identify which bottle the impurity is present in. But suppose in the first case when you are testing a sample of 1 and 2, so you have done one test and this returns pure, then it is imperative that bottle 1 and bottle 2 are 100% pure. So the impurity is either in 3 or in bottle 4. Now test a small sample from bottle 3. If it returns pure, then you can say that the impurity is in bottle 4. If it returns impure, then obviously the impurity is in bottle 3. So again, even in this case, just by conducting 2 tests, we can identify which of the 4 bottles contains that impurity. Let us now look at the last question. There are 4 bottles. It is known that out of these 4 bottles, either 1 bottle is pure and 3 bottles are impure, or 2 bottles are pure and 2 bottles are impure. One of these 2 cases is true. And whenever there is impurity, that impurity contains 85% pure and 15% impure. Now let us mix equal quantities from each of the 4 bottles. And what is the percentage impurity in the first case? In the first case, P will give 0% impurity. The remaining 3 will give 15% impurity. So the average impurity in the sample will be whole of this divided by 4, which is equal to 45% divided by 4, which is 11.25%. So in the first case, if there is only one pure bottle and 3 bottles which are impure containing 15% impurity, if you are mixing equal quantities from each of the 4 bottles, the percentage impurity will be 11.25%. Now if you are conducting a test, purity test on this sample, it will return impure. In the second case, suppose at the start there were 2 bottles which are pure and 2 bottles which are impure. What is the percentage impurity in the sample? It will be 0% in the first bottle, plus 0% in the second bottle, plus 15% in the third bottle, plus 15% in the fourth bottle, divided by 4. This will be equal to 7.5%. Now because this is less than the threshold of 10%, when a test is done, this is going to return that the sample is completely pure. So if you are trying to figure out whether the initial sample has 1 bottle pure or 2 bottles pure, what we need to do is collect equal amount of liquid, small amount of liquid from each of the 4 bottles and conduct a test. If the test returns pure, then it is case 2. It would imply that at the start there were 2 bottles which are pure. If the test returns impure, then it would imply that it is the first case where there is only 1 bottle which is pure. So this would imply that just by conducting one test, we can figure out whether at the start there was 1 bottle which was pure or 2 bottles which was pure. So the required answer is only 1 test is needed.
DILR feels unpredictable. It's not luck, it's a smart set selection. Many fear DILR, but how does CAT actually frames the paper? There are definitely solvable sets when you learn to navigate and pick sets from your comfort zone. And for set selection strategy, PYQs are your best resource. We team Cracku have compiled CAT DILR questions all at one place. Just Google CAT DILR questions to practice, analyze, watch video solution and download PDFs.